Okay, for 10b, they want us to show that x to the negative second is not equal to big O of cotan x as x approaches 0. Well, what our approach here is to assume that it is and get a contradiction. Okay, so let's suppose that the absolute value of 1 over x squared is less than or equal to some constant times the absolute value of cotan of x, okay, for x approaching 0 for small values of x. Well, let's do some arithmetic on this. Multiply both sides by cotan, right? By tan of x, and that gives me that absolute value of tan of x over x squared is less than or equal to a constant. Well, does that cause a problem when x is equal to 0 or getting close to 0? Well, let's see. Okay, let's see what happens when we take the limit as x approaches 0 of tan of x over x squared. This is a 0 over 0 indeterminate form. So L'Hopital's rule applies. So the derivative of the denominator is obviously 2x. The derivative of the numerator is secant squared x. And here, okay, we're done because the numerator limits to 1, the denominator limits to, well, here it'll depend on whether we are getting close to x from above or below, because we'll either go to plus or minus infinity. But the upshot here is neither plus nor minus infinity is going to be bounded by this c. Okay, so if I want to be, if I want to now work backwards from this and be proper, I would calculate the limit as x approaches 0 from above of tan x over x squared, and the limit as x approaches 0 from below of tan of x over x squared. But you get the drift on this.